Today we're going to cover cosine law, and that we use on this type of a triangle. So here we have a triangle. We have angle A is 36 degrees. We have one side of 3 centimeters and another side of 6 centimeters. And if you look at this triangle and analyze it, you see that we can't use the law of sines because we have no corresponding angle and side. This type of triangle is known as a side angle side, so SAS triangle, and that'll require us to use cosine law. So law of cos is a squared equals, and that's what we're going to solve for side A squared equals b squared plus c squared, subtract 2b c, and then cos of angle A. So A squared equals, this is our C, this is our B, side B, squaring both of those sides, subtracting the product of those two sides twice, and then times, multiplying times the angle. So let's put in our substitution. A squared equals B is 6 squared plus 3 squared, subtract 2 times 6 times 3, and then cos of 36. And then we get, I'll show you how to input that into your calculator. I'll show you how to enter it into your calculator. I'm going to show it to you in two different ways. First, we're going to do it as a two-step. So I have a squared equals 6 squared plus 3 squared, subtract 2 times 6 times 3, cos of 36. Hit enter and I have that. But that's a squared, so I don't want a squared. So I'm going to take the square root of that, second square, and then second answer, which calls up the 15.87, and then press enter. And I now have my side A, not side A squared. Okay, now I'll show it to you as a one-step. And this is the one I generally use. Put in the square root first, so I've got that, and now everything else is the same. 6 squared plus 3 squared, subtract 2 times 6 times 3, cos of 36, and we get right to the 3.98888. All right, so we have 3.984393078. So down here we have A equals 3.984393078, and we're going to round it to the nearest hundreds. So we get 3, we actually get 4.00, and units of measure was centimeter. And that's all there is to that. I'll walk you through another example just so that you're solid on it. All right, here we have another triangle of the SAS type, side angle side. So we have to use cos. So you notice there are no, it's not labeled ABC. If it's helpful for you to label it ABC, so we have an ABC triangle, go for it. If not, I'll show you. I'm not going to. Just write out the equation, subtract 2bc cos of angle A. I know that I have to include these two sides as my B and C, so B and C there, and this one, so it's rather irrelevant if it's called A or B, but if you need to call it A and B, and that's helpful for you, do it. Okay, our substitution, A squared equals 18 squared plus 30 squared, subtract 2 times 18 times 30, and then cos of 45 degrees. All right, I'll show you again how to input that. Entering this into the calculator, I have x squared, and I'm going to go right to the x equals, so second square root, so I'm going right to that function. 30 squared plus 18 squared, subtract 2 times 30 times 18, and then cos of angle 45, and I get 21.455555, etc. 455178831. Okay, so we get x equals 21.4551783, and it's a side line, so we're going to round to the hundreds. We have 21.46 units of measure. And that's that. Here we have another diagram where we're going to be solving for angle A. So that's going to be what we're solving for. And as you can see on this one, all we have given is 3 sides. So again, we know that it's going to be cos sine law that we have to use. Given 3 sides, solving for the angle. All right, I'm going to show you now how to use cosine law to solve for an angle. As we see on the diagram, we've only got the 3 sides. So in order to do this, we have to change our equation so that we've got the cos A isolated and the sides are what we're going to be dealing with. So it looks like cos A equals B squared plus C squared, subtract A squared, the opposite matching there, divided by 2 times B times C. And then we just put in our substitution and do our solving. So we've got 8.9 plus 12.6, subtract 14.7, and these are all squared, divided by 2 times 8.9 times 12.6. And then we just input it into our calculator, and we're done. This is how you enter this to solve for an angle in the calculator. Because we have only side measurements that we're inputting, we need to use the second cos to convert it to the angle. So second cos, and then I will put another bracket that's for my numerator. 8.9 squared plus 12.6 squared, subtract 14.7 squared, and my numerator divided by my denominator also has to be bracketed because there's more than one item. 2 times 8.9 times 12.6, and my bracket, and I have my unrounded number for my degree. And we get 84.40151261. Cos A equals 84.40151261. We'll round the angle to the 10th, so cos theta equals 84.4 degrees. Okay, here we have another angle another triangle with 3 sides given, and we're solving for angle theta. Again, we're using the formula where we've got cos of angle A isolated. So then we just do our substitution. Cos A equals 19 squared. Our triangle is not labeled, so we don't have the ABC in there. If it's helpful for you to label it, go ahead. You don't need to, as long as you're paying attention that the angle cos A, and that's the subtraction one, the B and C and the B and C are the same. So as long as you're paying attention to that from your diagram, you can just fill it in without relabeling your diagram. So we've got 19 squared plus 12.2 squared, and these again, it doesn't matter which is B and C, but then subtracting the 14 squared, which is opposite the angle we're solving for, and then 2, 19, and 12.2. And again, then we just input it into our calculator, and we're going to get the degree measurement for the missing angle measurement. Okay, now we're ready to input our equation. I'm going to do it as if I've forgotten to second function it, to second cos. So I'm going to bracket my numerator, 19 squared plus 12.2 squared, subtract 14 squared, and my numerator divided by, begin my denominator, 2 times 19 times 12.2, enter. and I have a number that looks like it's not going to, it's an odd number for an angle. So then I realized, oh, I've just forgotten to second cos, and that's easy to correct at that point. Instead of retyping it all, just go second cos, and then second answer, enter, and then I have my unrounded. And we get cos A, or cos theta, equals 47.39323329. And again, we're going to round to the 10th. So cos theta equals 47.4 degrees. And that's all there is to that.